The 10th century Islamic world produced many scholars famous for their questioning and correction of long-held Greek mathematical and scientific ideas. One of the most influential of the time was Thabit ibn Qurra, a translator, mathematician, astronomer, poet, and musician, as well as a great contributor to the field of medicine. He is remembered by modern scholars as one of the greatest translators and revisers of the Greek scientific works by Ptolemy, Archimedes, and Apollonius. But Thabit ibn Qurra was far from just a translator, and is credited with the writing of dozens of original treatises. His most famous contributions to mathematics include original proofs of the Pythagorean theorem and elaborations of Euclid's theories concerning amicable numbers. Thabit ibn Qurra began his work as both a translator of Greek texts and a court astronomer to Caliph al-Mu'tadid. Little is known about Thabit ibn Qurra's early life. Born in the year 836 in Haran, Mesopotamia, located in what is now Turkey, the scholar worked as a money changer. He eventually relocated to Baghdad in order to join the scholarly circle of the Banu Musa, who patronized his scientific and mathematical activities. Thabit ibn Qurra's invitation into this circle, as well as his talents in translation, were largely products of his religious background. Thabit ibn Qurra was not a follower of Islam. Rather, he was a member of an astronomical cult who called themselves the Sabians. The Sabians followed a Hellenistic faith that focused on devotion to the stars. Though they were a religious minority, they were considered to be people of the book and allowed to freely practice their faith. This background provided Thabit ibn Qurra with impressive linguistic knowledge in Greek and Arabic, as the Sabians based themselves in the Greek tradition. He mastered the two major languages of science in the Islamic world at this time. Thabit ibn Qurra's ability to translate made him very appealing to the Banu Musa, and he moved to Baghdad to work for them. This is where the scholar would remain for the rest of his life, most likely spending at least 30 years in the city and completing his most influential work there. Thabit ibn Qurra's most famous translations from Greek were books 5 through 7 of On Conics by Apollonius and Lemata by Archimedes. However, in addition to the creation of his own complete Arabic translations, Ibn Qurra also revised Arabic translations of famous Greek texts that were completed by earlier scholars. In particular, the most important of these was the revision of the translation of Ptolemy's Almagest that was completed by Ibn Ishaq in the 9th century. These revisions exist today in manuscript form only, but there is much evidence for their impact on later scholars' understandings of Ptolemaic concepts, including the famous Al-Tusi of the 13th century. One of the most important contributions Thabit ibn Qurra made to mathematics was the generalization of the Pythagorean theorem. Although the theorem is as old as time, with the Babylonians first discovering it, Thabit left his mark on the iconic theorem by creating a generalizing proof. Using the vast wealth of Euclidean knowledge learned from his translations, he uses a proof method to derive the iconic formula we know today, a squared plus b squared equals c squared. The geometric proof is given by reassembling two smaller squares into one larger square, a method Ibn Qurra called reduction and rearrangement by recomposition. The proof works by proving the congruence of the figures on each side of the Pythagorean equation. Another important contribution made by Thabit ibn Qurra to math was his work on amicable numbers. Amicable numbers are an important concept in the branch of math called number theory. A pair of numbers is considered amicable if the numbers that can divide one can be added together to equal the other, and vice versa. For example, the smallest pair of amicable numbers is 220 and 284. Amicable numbers and the related concept of perfect numbers are still an active area of research in modern mathematics, as there are many open problems about them. The pair of amicable numbers discovered by Thabit ibn Qurra was 17,296 and 18,416. He devised a formula and used it to find the pair by setting n to 4, making p equal to 23, q equal to 47, and r equal to 1,151. All of these numbers are prime, so the equation checks out. The divisors of 17,296 add up to equal 18,416, and the divisors of 18,416 add up to equal 17,296. Thus, the numbers are amicable. In this manner, Thabit ibn Qurra was able to lay out a much simpler solution to the problem of amicable numbers than mathematicians before him. In addition to this, Thabit ibn Qurra applied his mathematical knowledge to make advancements in the field of astronomy. This helped establish a tradition of mathematical precision in astronomy, which influenced later scholars such as Kazimi and Nasir al-Din al-Tusi. His surviving astronomical works address problems such as the determination of crescent visibility, the construction of sundials, and the unequal motion of the sun and moon. He additionally challenged Aristotle's ideas about the cosmos, rejecting the concept of essence as immobile and allowing the use of motion in mathematics. Through these discoveries, he contributed to a tradition of doubting Greek astronomy that was picked up by Copernicus. Thabit ibn Qurra was a true scholar, whose work played a fundamental role in a variety of fields ranging from astronomy to mathematics and translation. His unique background allowed him to tap into a wealth of knowledge he utilized to his fullest extent. When discussing the history of mathematics, it would be remiss not to mention his name.